So previous class we have already discussed about LCR circuit and resonating frequency. The value of resonating frequency omega r is equal to 1 by root over LC and omega equal to 2 pi fr. That is fr is equal to 1 by 2 pi root over LC. So this circuit is called resonant LCR circuit. This frequency is called resonating frequency. The resonating frequency f r is equal to 1 by 2 pi root over LC. Clear? So a series LCR circuit, when current is maximum, that is omega L is equal to 1 by omega C. So current becomes maximum. Then we will discuss. We discussed the graph, current graph, and see that. So current will decrease. Maximum value of current will decrease in according to the increase of omegas r in both sides. Okay. So now we will discuss about LC oscillations. So LC oscillations. So LC oscillations, qualitative idea. L means inductor, C means capacitor. So consider an inductor of inductance cell. So it is connected with capacitor of capacitance C, and the capacitor is connected to a battery. If there are two keys, so we have already known that the energy stored in a capacitor, the energy stored in a capacitor that is electrostatic potential energy. Okay, so U is equal to half Q square by C. Okay, in the form of electrostatic energy. Clear? Similarly, the energy stored by an inductor, the energy stored in a inductor or by a inductor is given by UB in the form of magnetic energy. Okay, half Li square, half Li. So LC oscillation means the electrostatic energy and the magnetic energy repeated by the process of a LC circuit. So inductor circuit of inductance cell and capacitor circuit of capacitance C. So we will discuss how LC oscillation occurs. Okay. So consider a inductor of inductance cell is connected to a capacitor. When the key K2 is closed, initially the capacitor has no charge. So this is called the charging condition of the capacitor. When the key is pressed, so charge goes from positive terminal to negative terminal. So this is called charging condition of the, so charging condition, this is called charging condition of the capacitor. Okay, so when K2 is closed, so that is called charging condition of the capacitor. So at a particular after some time, at an instant, the capacitor is fully charged. So after some time, after some interval of time, or after some time, the capacitor is fully charged. Let the charge of the capacitor at Q. So this condition is called charging condition of the capacitor. Okay. So now when K1 is closed, now the current flows from positive end to negative end. But initial condition, when charge is equal to Q, so current I is equal to 0. So here when the capacitor is fully charged, now the current is equal to 0 in the circuit. When the key is open, when K1 is open, so current is equal to 0. So total energy stored in the capacitor, that is total energy stored in U is equal to half U square by C. Okay, if we will draw a graph, so at first, so charge is maximum, so charge becomes maximum, so Q, jodi koribi Q out I graph according to time, so charge becomes maximum and current becomes 0. So current becomes 0. Clear? So here current becomes maximum to 0 as hala, but charge becomes 0 to maximum charge. बुझा बोला? Now here when capacitor is fully charged, current is equal to 0. The total energy stored in the capacitor is equal to half Q square by C. Clear? When Q1 is closed, what happens? So the capacitor is allowed to discharge. When the K1 is closed, so K1 is closed, the capacitor is allowed to discharge. The capacitor is allowed to discharge. Discharge habo, so discharge hole kon hobo bile dekho ite previous case re ita kon thila open thila ita close thila, so battery pray charge like store hela capacitor re, so total charge store hela in the form of electrostatic potential energy. Clear? But current re ei circuit re current thila 0 thila, so total energy in the form of electrostatic potential energy stored in the capacitor, that is U is equal to half Q square by C. So now when the key K1 is closed, so what happens? The capacitor is allowed to discharge. It discharge habo, so charge send koriyo, ए circuit रे कोन हबो, current flow हबो. Okay, so maximum current केटा हबो, let I naught. So maximum current केटा हबो, I naught flow. So in this condition, so कोन हबो, in this case maximum current I naught. So energy केटा हबो store हबो na in the form of inductor in the form of magnetic field by the inductor. Okay, so after some time what happens? So after some time, let the current is I. Okay, so the total energy is partially electric energy and partially magnetic energy. Okay, that is U is equal to half let Q naught by C and U B is equal to half L I square. Okay, so the current goes maximum value I naught. So there is a equation U is equal to 0. Then when maximum current I naught flows, so the charge becomes 0. So charge becomes 0. That is called discharge condition. And U is equal to U B is equal to half L I naught. Okay, so this is called discharging condition of capacitor. But when the capacitor is full charge, now the energy is equal to in the form of capacitor. But after some time, it is partially electrical energy and it is partially magnetic energy. But a particular instant, so current is maximum, that is I naught. So when current is maximum, the charge becomes 0. So charge becomes 0 and the total energy stored in the form of magnetic energy by the inductor. So that is half L I naught square. Clear? So what happens here? Now the current becomes maximum and charge becomes minimum. So charge becomes minimum. So here charge becomes minimum, but current becomes maximum. But here charge makes 0 to maximum, current maximum to 0. But here charge becomes 0, current becomes maximum. But when current maximum, then now current flows from inductor. But this inductor opposes the current. But the inductor opposes the current. We have already discussed in Lenz's law. But the current opposed by the inductance L. So the polarity of the capacitor reverses. So this is plus and minus. This is plus, this is minus, this is also called. Then it is also in the charging condition. So now the charge becomes okay. The charge becomes maximum, but it is reverse polarity. but it is reverse polarity, or it is reverse polarity. Reverse polarity. Okay, so plus ता minus हेला, minus ता plus हेला. एटा देखो charge कौन थिला, so charge is maximum, so charge is maximum, but charge what happens, so charge is maximum in reverse side. Okay, now current also maximum to 0, but in reverse direction. Reverse direction. Okay, so there is a oscillation of, this is a sine curve, so this is a sine curve, this is a cosine. So when the capacitor is allowed to charging and discharging, so there is a oscillation. So electrical energy is converted into magnetic energy, and magnetic energy is converted into electrical energy. Electrical energy is converted into magnetic energy, and magnetic energy is converted into electric energy. Here देखो ग्राफ रे कोन होची, तो एटा कोन होची, मन करंट मोटा नेबी, so current कोन होची, current 0, so charge maximum at initial time t equal to 0, charge is maximum, current is equal to 0. So after some time कोन होची ना, current ता maximum होची, charge ता कोन होची 0 होची, तापर कोन होची, जब current इंडक्टर करंट को अपोज करची, एटा फास्ट कोन होची टोटली इलेक्ट्रिकल एनर्जी. सो टोटल इलेक्ट्रिकल एनर्जी केते, U is equal to half U square by C. Okay, so एटा जो K1 is pressed or closed, so current flows from this capacitor, so this is called discharging condition of the capacitor. So positive plate to jibo, negative plate to asibo. Okay, so current habo, current ro maximum value habo, but after some time, so the energy, electrical energy is partially converted into magnetic energy in the form of inductor. But at maximum current, total electrical energy is converted into total magnetic energy by the inductor. So here total electrical energy is converted into total magnetic energy. Okay, so when the current is flows through the circuit, so now the capacitor is in the form of charging condition. Why? Because the induced current or this current opposed by the inductor, so this is the reverse polarity, this is the plus, so plus, this is the minus. So reverse changes, but in reverse direction, what? Charge increases. So charge increases in reverse direction, but current decreases in reverse direction. Okay, so this is charging condition. The total electrostatic potential energy by the capacitor, but during discharging condition, the total energy is converted into magnetic energy, then repeats its cycle downward, that is negative cycle, because the capacitor is when charging condition, this is plus of the battery plus, minus of the battery minus. When discharging occurs, so away from the positive charge. Okay, now the current is opposed by the inductor, hence the charging condition now occurs, but in the negative cycle. Charging condition hoji, but what hoji, negative cycle hoji, negative, because the polarity of the capacitor changes, because the capacitor polarity kona hoji, change. So kona hoji na oscillation hoji. Ita gote sila, ita kona, ita oscillation, ita bi kona la, ita oscillation ro. बुझा बोला नहीं. So LC oscillation meaning when a capacitor is connected to a non-resistive inductor, कौन होची ना, electrical energy stored by the capacitor is converted into magnetic energy by the inductor and vice versa. जेते बेले कौन होची, गोटे कैपेसिटर गोटे नॉन रेजिस्टिव इंडक्टर सहित कौन करा होची, कनेक्शन करा होची, से कौन होची ना, गोटे पार्टिकुलर टाइम रे इलेक्ट्रिकल एनर्जी मैग्नेटिक एनर्जी रे कन्वर्सन होची, आ मैग्नेटिक एनर्जी ता इलेक्ट्रिकल एनर्जी रे कन्वर्सन होची, बट डायरेक्शन ता कौन होची, रिवर्स, पीरियडिकली रिवर्सेस होची. अर्थात कैपेसिटर जदि पोलैरिटी चार्जिंग कंडीशन रे प्लस माइनस थाती, ताहाले डिस्चार्जिंग कंडीशन रे कौन होची, नेगेटिव रु पॉजिटिव होची. क्लियर. So electrical energy is the main LC oscillation काहे कहला ना, electrical energy काहे ना, wave motion रे energy रो ट्रांसफर होची, energy ऑसिलेशन कथा माने पबो ऑसिलेशन रे कोन बोलची ना पार्टिकल इज वाइब्रेटिंग इट्स मीन पोजीशन बट एनर्जी ट्रांसफर फ्रॉम वन पॉइंट टू another point. Similarly here in electrical circuit of inductance L and capacitance C, the electrical energy is converted into magnetic energy and the magnetic energy is converted into electrical energy, but the polarity is reversed. So that is called LC oscillation. Clear? So there is a qualitative idea in your syllabus. So what do you mean by LC oscillation? When a capacitor circuit is connected in a non-resistive inductor circuit, the electrical energy is converted into magnetic energy and the magnetic energy is converted into electrical energy, but in periodically reverses direction. So this is called LC oscillation. Okay, so this is all about your LC oscillation. Means electrical energy is converted into magnetic energy and magnetic energy is converted into electric energy. This is the diagram. So this is the inductor. At first, when P2 is closed, the capacitor is fully charged. U is equal to total charge is equal to Q, but the circuit current is equal to 0. When K1 is closed, so current flows in the circuit, but the polarity of the capacitor is reversed. So that is all about LC oscillation. Okay. So now we will go to transformer. So transformer is an electrical device. You have already associated with a transformer in village, your substation, and any lane of the electrical substation. तुम सब transformer देखिचो, तो transformer नाट सुनथिबो होला. So in second year or first year, any type of device you are associated, you are familiar with any type of device, that is first galvanometer, moving coil galvanometer, potentiometer, meter bridge, all about the instrument we have, ammeter, voltmeter. Okay, all uses are also associated with. You are familiar with the uses and what is the practical application of ammeter, voltmeter, how to connect ammeter and voltmeter in the circuit. Similarly, moving coil galvanometer. So what is the function of a moving coil galvanometer? What is its principle? Okay, all here. So any device come across the chapter, first we will define it. What is this instrument? Then we will what principle it works. So co-principle re काम करची. Okay, what is its construction? So what is its theory and formula? So this is common to all type of that is meter bridge, potentiometer, moving coil galvanometer. Now there is a new device, transformer. So transformer is a electrical device. So it is a device. So transformer it is a device. So it is a device which converts transformer. In the transistor thila tomoro low signal to high signal amplification. PNP transistor, NPN transistor. Transistor as an amplifier. Similarly, so transformer it is a device which converts low voltage at high current, low voltage at high current to high voltage at low current and vice versa. It is a device which converts low voltage to high voltage. Low voltage but current कौन सा पड़ियो? High current होया. But high voltage at low current also possible and vice versa is also possible. So it is a device transformer. Low voltage at high current to high voltage at low current. So that is called transformer. So transformer is the device which converts low voltage at high current to high voltage at low current and vice versa. Okay. So transformer is the device which converts low voltage at high current to high voltage at low current. Here principle. Who principle eta theorem. It works on the principle. It works on the principle. It works on the principle of mutual induction. Mutual induction. So one mark will be important. It a co-principle theory. So it works on the principle of mutual induction. Mutual induction when there is a change in magnetic flux in a primary coil, so an EMF is produced in a secondary coil, or when there is a change in magnetic flux in the secondary coil, an EMF is produced in a primary coil. So that is called mutual induction. So it works on the principle of mutual induction. Here, so this is transformer, this is the principle. Then construction. So construction में जो हम देखिए ताल कौन दीटा कॉइल लगे गोटे प्राइमरी कॉइल सो प्राइमरी कॉइल गोटे होची सेकेंडरी कॉइल सो प्राइमरी कॉइल रो नंबर ऑफ टर्न्स होची एनपी सेकेंडरी कॉइल रो नंबर ऑफ टर्न्स होची एनएस प्राइमरी कॉइल रो नंबर ऑफ टर्न्स होची एनपी सेकेंडरी कॉइल रो नंबर ऑफ टर्न्स होची एनएस गोटे लैमिनेटेड गोटे आयरन कोर गोटे ओके कोन बुझे देखो कंस्ट्रक्शन रे सो रेक्टेंगुलर कॉपर स्ट्रिप्स अछि समझे रेक्टेंगुलर कॉपर स्ट्रिप्स ओके इन द कॉपर स्ट्रिप गोटे पर गोटे कठा लगाई गोटे कोन हो ना एटा प्राइमरी कॉइल सो प्राइमरी कॉइल ओके एटा हो सेकेंडरी कॉइल ओके एटा हो आयरन कोर here the primary coil it is the secondary okay so transformer is a device which works on the principle of mutual inductance or mutual induction so construction to the secondary coil or the primary coil number of turns will be np secondary coil number of turns will be ns so iron copper coil अछि iron core so core रे कोन कराई थी इन्वर्टेड कॉपर स्ट्रिप्स रेक्टेंगुलर कॉपर स्ट्रिप्स so rectangular iron strip one by one कोन कराई थी कनेक्ट कराई थी एगोटे प्राइमरी कॉइल कनेक्शन कराई थी नंबर ऑफ टर्न्स तार एनपी सिमिलरली एगोटे सेकेंडरी कॉइल अछि तार नंबर ऑफ टर्न्स केते एनएस r number of turns होची np if there is a change in magnetic flux in the primary coil according to Faraday's law of electromagnetic induction and emf is produced in secondary clear so now we will discuss what is the theory and what is the transformer equation and what is the efficiency so this is the definition of the device what is a transformer it is a device which converts low voltage at high current to high voltage at low current so the power loss is small काहे ना low voltage रे high current दोछ but high voltage रे low current बुझा पड़ला ना transformer not a producing device so this is a transformer means low voltage at high current to high voltage at low current and vice versa this is the principle it works on the principle of mutual induction what is the construction So there is a rectangular iron strips one upon another, then wounding copper wires are wounding in number of turns. Primary coil is NP and number of turns in secondary coil is NS. Okay, if it is low voltage, then becomes it is high voltage. If it is high voltage, it becomes low voltage. Clear? So this is all about transformer principle and construction. Now we will go to type of transformer. So type of transformer. So there are two types of transformer. One is step-up transformer. Step-up transformer. Second is step-down transformer. Step-up transformer, step-down transformer. कौन step-up transformer? तबे पचटी परीक्षा रे what is step-up transformer and step-down? So step-up, step-down, step-down. So step-up transformer in number of turns of secondary coil is greater than number of primary coils. EMF produced primary coil is greater than EMF produced in the secondary coil. Okay, but current in the primary coil is greater than current in secondary. This is called step-up transformer. Similarly, step-down transformer, number of coils in primary coil is greater than number of turns in the secondary coil. EMF in primary coil is greater than EMF in secondary coil. And current in the primary coil is less than current in secondary coil. That is called step-down transformer. So there are two types of transformer. One is step-up transformer and another is step-down transformer. So this is the condition to be a step-up transformer. This is the condition to be a step-down transformer. Okay. What is the transformer equation? So transformer equation कौन होगा? Transformer equation that is E primary by E secondary, okay, is equal to number of primary divided by number of secondary is equals to current secondary by current primary. Okay, or you can write E1 by E2 is equals to N1 by N2 but I2 by I1, because current and EMF is inversely proportional to each other, because here 1 and 2 but here 2 and 1. So the transformer equation, so the ratio of primary EMF to the ratio of secondary EMF is equal to number of turns in primary coil to the number of turns in the secondary coil, but current in the secondary coil to the current in primary. Clear? So this is the transformer equation. This is transformer EMF and current equation. Okay. So there are two types of transformer. One is step-up transformer. Second is step-down transformer. So what is the condition to step-up transformer? So number of primary coils is less than number of secondary coils. So EMF induced in primary coil is less than EMF induced in the secondary coil, but current in the primary coil is greater than the current in the secondary coil. So step-down transformer is the reverse. NP greater than NS, EP greater than ES, IP is less than IP. So this is the equation. How it is derived? It is derived from the Faraday's law of electromagnetic induction, that is E is equal to how much? N minus N into d phi by dt. Clear? So EP primary, then second. Clear? So now, so this is all about the transformer. So uses of transformer and losses of transformer. So uses So in different electrical circuit, TV, radio, so any electrical device tuning circuit, the most electrical applications uses the transformer for low voltage to high voltage. Similarly, now we will discuss the losses of transformer. Some losses of transformer due to some energy loss of mutual induction. So some losses you have to remind it, that is the iron loss, low SS, yes, copper loss, hysteresis loss, okay. So these losses are due to the transformer. You have to remind it, iron loss, copper loss, and hysteresis. Okay. So now transformers is already over. So alternating current of 12th class is already over. So next class we will discuss about nuclear chemistry and atomic physics.